Hello, Matthews Gatos here. In our last problem here, we're going to look at how to solve multiple right triangles with an angle of depression this time instead of an angle of elevation. Okay, so we've got Dave. He's in an office, and from his office window, he looks out and he sees a bus moving away from the office. The first time he looks at it, the angle of depression was 46 degrees, and then it changes the next time he looks at it to an angle of depression of 22 degrees. So I want to determine how far the bus has traveled from the first time he saw it to the second time that he saw it if his window is 100 meters above the ground. So very first thing I like to do is to draw a little sketch of what this looks like. So this is not drawn to scale, it's just to kind of help us place everything. So here is Dave's office window, and it's 100 meters above the ground. Now he looks out his window and he sees the bus first at an angle of depression of 46. So he has to look down at a higher angle because the bus is actually closer to him. So from the horizon, he looks down at an angle of 46 degrees. Now, we don't want to work with an angle of depression outside the triangle. We want to work with an angle of elevation inside the triangle. So remember our properties of parallel lines. This would be those Z angles, alternate interior angles, and that would be 46 degrees right here. Okay, so I want to find the distance that the bus moved. So this is the first time that I see the bus. I'll call it bus number 1. So I'm looking for this side, which is adjacent. Now looking at the 46-degree angle, this side is opposite. So O's and A's, that's tangent. So let's write that out. So tangent of 46 degrees is going to be opposite over adjacent. So tan of 46 is going to be opposite, which is 100. Over adjacent, which we're trying to find. Let's put that over 1, and then I have a proportion, so I can just cross multiply and divide what's left. So 1 times 100 divided by tan of 26. So I do that, and I get that the first time he sees the bus, it's approximately 97 meters away from his window. So I'll label that over here, and we'll say that this is approximately 96.56, etc. And we're going to leave that in our calculator. We're going to use the unrounded value. Okay, so just to make my drawing a little bit neater, let's do that again for the second time that he sees the bus. So again, he's still 100 meters above, his window is 100 meters above the ground. Now the second time he sees the bus is at an angle of depression of 22. So he doesn't have to look down quite as far because the bus is moving away. It's further away from him. So this is where the bus is the second time that he sees it. So again, using those Z angles, I don't want an angle of depression outside, I want an angle of elevation inside. So I can use those alternate interior angle properties and call this 22 degrees. So I'm now looking at this big triangle here. So I want to find where the bus is the second time. So again, this whole side here is still adjacent. This is opposite. Opposite over adjacent, still using tangent. So I'll do tangent of 22 degrees is opposite 100 over adjacent A. Put that over 1, and then I can again cross multiply and divide. So doing that, I can get the second time that he sees the bus. So the distance should be a higher distance. So putting that into my calculator, I can see it's approximately 248. So we know that this distance here is 247.50, etc. So if I want to know how far the bus traveled, I would just take how far it was when it was furthest away to how far it was when it was closest, and that tells me how far away it traveled. Again, use your unrounded values, not your rounded values, to avoid some errors. So I take the bus 2 distance minus my bus 1 distance, and I can see that it traveled a distance of approximately 150.9. Now, how did the question want us to round? It said to the nearest whole meter. So that means I can say the bus traveled 151 meters. So hopefully that with angle of depression makes sense to you. Remember, angle of depression outside, we will use the equal angle of elevation inside the triangle. So I hope this video helped. If it did, give it a thumbs up so I can help more mathies just like you. Thanks for watching, and I'll see you for the next one.